Hi, I am Shahul Amir, working as Professor EC Department, Sedurusha Technology, Pullur Karyapati. In this session, we are going to discuss a problem which is related to linear control engineering, in particular state variable technique. In particular, I can say about we are going to find the state model for a given differential equation. So I'll read the problem statement, then we will discuss how to solve the problem. The problem statement is: construct a state model for a system characterized by differential equation d cube y by dt cube plus 6 d square y by dt square plus 11 dy by dt plus 6y plus u is equal to 0. Give block diagram representation, and also we are going to examine the controllability and observability of the system. Okay. So here they have given a differential equation. For this we are going to find the state model. Okay. Here the highest order of the system is 3. So we have 3 state variable x1, x2, x3. Okay. So using that we are going to form state matrix. So first state variable x1 is equal to y. Second state variable is x2, which is equal to dy by dt, first order differentiation. x3 is equal to second order differentiation of y, that is equal to in fact first order differentiation of x2. x3 is x3 dot, if we are further differentiating the equation which is x3, we will get x3 dot is equal to the third order differentiation of the previous one, that is d cube y by dt cube, okay, is equal to here another differentiation, that is x double dot of x2 double dot. Now we are going to substitute all these things in the system equation. So here the system equation is d cube y by dt cube. d cube y by dt cube is this one, that is x3 dot. Okay, so I am just substituting x3 dot plus 6 into d square y by dt square. d square y by dt square is nothing but x3. Then 11 dy by dt, 11 dy by dt, so 11 dy by dt is x2. Okay, x2. Then plus 6y, y is nothing but x1, it is here, plus u is equal to 0. So we have written the system equation in terms of state variable. x3 dot is plus 6x3 plus 11x2 plus 6x1 plus u is equal to 0. Okay. Now as far as the state variable is concerned, we need x3 dot, because the state equations are formed like x dot is equal to a into x plus b du y is equal to c into x plus d into u. So we need to form x dot. So I am just keeping x dot here and I am pushing all the things, variables right hand side. When I am pushing it, I will get x3 dot is equal to 6 minus 6x1 minus 11x2 minus 6x3 minus u. So we have 3 state equation. First one is x1 dot is equal to x2, x2 dot is equal to x3, and x3 dot is equal to this one. So when you are seeing this here, x in this equation x1 is missing, the coefficient x1 is 0. We can write like x0 x1 plus x2 plus 0 x3 plus 0 u. Similarly, when we are writing this, 0 x1 plus 0 x2 plus x3 plus 0 into u. This is the way we can write this, we can understand like that. And here when we are taking third equation, x1 coefficient is minus 6, x2 coefficient minus 11, x3 coefficient minus 6. Here these are all 0 and here we have full coefficient. Based on that, I am forming matrix. So first I am taking x1 dot, x2 dot, x3 dot, this one, and I am writing the equation already I have given. So here x1 coefficient is 0, x2 coefficient is 1, and x3 is 0, and u is also 0. Similarly, second equation, x1 0, x2 0, x3 is 1, and u is also 0. Third one, x1 coefficient is -6, x2 is -11, and x3 is -6, and u is -1. So this is input equation, and the output equation is y is equal to x1, and the first y is equal to x1. So here in this case, that is, output is purely depends upon x1, and x2 coefficient is 0, and x3 coefficient also 0. So y is equal to 1 0 0 1 0 0 into x1, x2, x3. For this, we need to draw a block diagram. So first question is we have to draw block diagram. Okay, and so you can draw from left to right and right to left. I am just taking drawing from right to left. So right is output. Output is y. Y is equal to x1. So I am just mentioning y, which is equal to x1. So we need to find x1 dot. X1 dot means we have to pass x1 dot via an integrator. So differentiation of, that is, integration of d by dt, both will get cancelled. For example, when I am passing d by dt, dx1 x2 by dt via an integrator, that is integrator, I will get x2. Okay, so if it is x1, then I will get x1. So I have x1, so x1 dot passed via an integrator, I will get x1. Similarly, here it is x2, so prior to the integrator, I will get x2 dot. Similarly, when we are passing x3 dot via an integrator, I will get x3. So first link is over. So we are starting with x3 dot, passing via integrator, I will get x3. When I am passing x3 is equal to x2 dot, when I am passing x2 dot via integrator, I will get x2. x2 is nothing but x1 dot, and I am passing via integrator, I will get x1. Now x1 dot, so here x1 dot is equal to x1 dot is equal to x2 is here. x1 dot is equal to x2 here. Okay, and x3 is equal to x2 dot is here. So two equations are there. The third equation we are going to form. Third equation is formed by linear combination of x1, x2, x3 and u. U is input. So coefficient of u is -1. So I am just taking input u and passing via a multiplier, which will multiply 1 with this u, and the output is here -u. Now I need x1 multiplied by -6. So I am just taking a lead from the output y, that is y is equal to x1, and I am just multiplying with the 6, and I am just taking, okay, then I am going to take x2 and multiply with 11. So I am just taking a lead from x2, and I am just multiplying with 11, and I am going to sum these two things. Okay, here output is 6 x1, and here output is 6 x2, and here I'll get 6 x1 plus 11 x2. Likewise, I have to take I have to think about 6 x3. So I'm just taking a lead from x3 and multiplying with multiply 6, and output is 6 x3. Now I am summing the result, this one and 6 x3. So here the output is sum of this one and 6 x3. So here I'll get 6x1 plus 11x2 plus 6x3. Now I am going to sum input and this equation. So here in fact here I have minus, okay, minus 6, minus 11 and minus 6. So here I have 6 plus, so I am just subtracting minus u and the term which I got from these summers. So I'll get here x3 which is equal to this equation, that is minus 6, okay, minus u minus 6x1, okay, minus 11x2 and minus 6x3, this equation. This is block diagram representation of the given state variable. Now we need to find controllability and observability of the matrix, okay, state matrix. So this is the state equation and this is the state space representation of the given model. Here this matrix is A and this matrix is B and this matrix is C and D is equal to 0. So we have ABCD matrix. Using this ABCD matrix we are going to check for observability and controllability. First we will I'm just writing the state equation. This we know, that is x dot of d t is equal to a into x1 plus b into u of t. Y of t is equal to c into x of t and d into u of t. So we have these matrix A, B, C, D. It's given here. We are going to use all these matrix to find the system is completely controllable or observable. To check for controllability, we need to form a composite matrix which is given by QC is equal to B, AB, A square B, and it will go up to AN minus 1B. This is called actually Kalman test. Okay, now n is number of states and here in this case n is equal to 3. Okay, so when we are substituting n is equal to 3 in the equation, I get QC is equal to composite matrix QC is equal to B, AB, A square B. Once we form the matrix, we have to find the determinant, and that determinant should not be is equal to 0. Okay, if it is not is equal to 0, then we can say that the rank of the matrix is n, and the state number that n, and we have to compare the state. If that rank is equivalent to number of state, then we can say that the system is completely controllable. For this case, n is equal to 3, so the rank should be is equal to 3. So if both are meeting this one, then we can say that the system is completely controllable. Okay, we will see whether we are meeting the condition or not. So we have B matrix and we have to find AB. AB is this is the A matrix and this is the B matrix, and when we are multiplying these two things, we generally, it's a simple matrix multiplication. We have to take first row and column. Okay, so for this I have written like 0 into 0 plus 1 into 0 plus 0 into minus 1. So we get 0. We get this 1 in fact. Okay, we get 0. First one is 0. The second is 0, 0, 1. So 0, 0, 1 multiplied by the 0, 0, 1. We get the answer is minus 1. This is explained here. And third row, so minus 6 into 0 plus minus 11 into 0 plus minus 6 into minus 1. So we get 6. So this is AB. Then we have to find out A square B. A square B we can write like A into AB. AB already we have determined. So if we are multiplying that value with the A, we will get A square B. So this is A matrix and this is AB. So when you are multiplying, so row column, so this is the first 0 into 0 plus 1 into minus 1 plus 0 into 6 is equal to minus 1, and then 0 into 0 plus 0 into minus 1 plus 1 into 6 which is equal to 6, and then minus 6 into 0 plus minus 11 into minus 1 plus minus 6 into 6. So this is 0 and this is minus 11 into 1 is 11 minus 36 we will get 25 minus 25. Okay, now we can form composite matrix QC. So this is B, this is AB and this is A square B. Now we have to find the determinant of this matrix. So the determinant is equal to 1. So you know what, we can easily find the determinant of the matrix. So first this element multiplied, that is this one, that is minus 1, that is 0 into minus 1, these components, minus 1 6 minus 25 minus 0 into this and this one, that is 0 minus 1 6 in minus 25 plus minus 1 into these elements to cross to matrix, that is 0 minus 1 minus 1 6. So these two term becomes 0 and the third one is minus 1, this one we have to find out. So minus 1 into minus 1 into 0 cross 6 minus 1 into minus 1. So this is 0 and minus 1 into minus 1 is 1, okay, and minus. So here minus 1 into minus 1 is 1. Now the determinant is not is equal to 0, hence we can conclude that the rank of the matrix is 3 and this is nothing but n. Okay, n is number of state. So we can say that the system is completely controllable. Similarly, for observability analysis, we need to form a matrix, composite matrix QO, which is equal to C transpose A transpose C transpose, A transpose square into C transpose, and it will go up to A transpose n minus 1 into C transpose. Here n is the order of the system. For this case, n is equal to 3. For that we have C transpose, A transpose C transpose, A transpose square into C transpose. Here we have C, already we have C 100 and A matrix we have. So if it is C, then C transpose, the row become column, C transpose. Similarly, so we need to find out transpose of A. This is A, okay, this is C transpose. A transpose, when you are taking transpose, the row becomes column, column becomes row. So here this row 0 1 0 and this row is become column and this row become column, third column, and like that. And we have to find multiplication of A transpose and C transpose is here, and the result is 0 1 0. Similarly, we have to find out A transpose square into C transpose. So we can write this one like A transpose into A transpose C transpose. This we have already determined, so we have to take A transpose and then C transpose, no, A transpose C transpose. So when you are multiplying, we get 0 0 1. Now we have to form the composite matrix. So composite matrix is this is C transpose, this is A transpose, C transpose, and this one is A transpose square and C transpose. So this is 1 0 0 and 0 1 0 and 0 0 1. So this is nothing but unit matrix. So magnitude of, that is determinant of Q naught is equal to 1 and is not is equal to 0. Then rank of the matrix is 3, which is nothing but is equal to n, that is number of states, that is also 3. So if the rank and the number of state both are same, then we can say that the system is completely observable. If you have any queries related to this problem, you can post in the comment section. So it's very important for me to answer the questions. Thank you very much.